Ahmed, are you there?
Thank you, Dr. Daniels. And first of all, my apologies for not being able to be there in person. I'd like to start by thanking the IOM and the organizers for the invitation to share some of the work that we've been doing in this area of genetic variation in response to caffeine. Just to start off with disclosure, I do hold shares in a company called Nutrigenomics, which provides genetic testing for personalized nutrition only for registered dietitians. And among the panel of genetic markers, we do have a test that affects or that relates to caffeine metabolism, determines whether your cell fast metabolized. Again, I also apologize for missing most of the talks earlier today. So I'm sure you've already heard a lot about some of the basic background on caffeine, which I won't repeat. And again, we're all familiar with really the main issue that I think brings us here. Many of these isolated case reports of premature death following consumption of an energy drink, usually in the context of some kind of physical exertion or physical activity, and of course primarily among the youth and adolescents. And a major issue, of course, is that a number of groups and individuals have is with the way these energy drinks are marketed, primarily to children and adolescents. And despite some denials, I think by some of the manufacturers, I think some of the marketing is quite evident that it does is meant to appeal to the youth. At the very bottom there, you might be able to see in fine print there, product not intended for children, but then we have Super Mario Brother. Other types of energy drinks, again, have that kind of marketing strategy that, again, is difficult to argue is not appealing to adolescents. Recently, at a high school in Winnipeg, Canada, Red Bull was giving out these certificates to graduating students and urging them to spread their wings and have a Red Bull. And of course, many of the high school students were under the age of 18. These slides were courtesy, the past 3 slides, of Jim Shepard. Jim's son Brian died a few years ago at a paintball event, and although not conclusive, there was reason to believe that the consumption of an energy drink at that event, which was the first time Brian had ever consumed one, may have acted as a trigger for that cardiac event. Other types of marketing strategies, again, from some of the manufacturers of these energy drinks. Here's one, cocaine, which was taken off the shelves from 7-Eleven stores, and at the top it says they're the legal alternative. Again, appealing to some of that risk-taking behavior that many of the youth and adolescents seek. Of course, there are other types of products that now we find caffeine in. Brownies, those are caffeinated gummy bears on the right there, caffeinated potato chips, all kinds of products. I think caffeinated gum is also on the market. Wrigley's had planned to launch one, but they've withdrew that. There was a case report in the Lancet a few years ago about a 13-year-old boy in Italy who was hospitalized and had tachycardia and elevated blood pressure, and it turned out later on that he had consumed a packet of gum that contained, 2 packets of gum that contained 160 milligrams of caffeine in each. And again, there was good evidence to suggest that this is what was responsible for these cardiovascular events that required hospitalization. Now, when we think of caffeine exposure, globally, coffee is still king. Coffee is the second most widely traded commodity. Oil is number 1. And certainly among adults in many parts of the world, coffee is still the biggest source of caffeine. Of course, a cup of coffee is no longer just a cup of coffee. Tim Hortons recently just renamed their cups, so by introducing this extra large at the far right end here, which is 24 ounces, contains several hundred milligrams of caffeine. I point this slide out because I think many of the manufacturers of energy drinks argue that if you're going to regulate energy drinks, you have to regulate coffee, because many cans of energy drinks have the same amount or the equivalent amount of caffeine as a cup of coffee. In fact, they argue that some other certain cups of coffee have even more caffeine than what's found in an energy drink. But I think it's important to make the distinction between caffeine from energy drinks versus caffeine from coffee. Now, obviously, the chemical structure, caffeine is caffeine. But the reason why I put this slide up is because I think there's a very big difference between a hot beverage that is generally sipped slowly versus a cold beverage that is often chugged. And so in terms of the peak concentrations of caffeine, it's very different when it comes from these two different kinds of sources or delivery systems, which I'm sure it has been referred to already today. Now, just going back to when we started exploring the link between coffee and cardiovascular disease, of course there have been dozens of studies that have examined this, and the results, not surprisingly, have been all over the map, many showing increased risks of cardiovascular disease, some showing no effect, and others showing a decreased effect with moderate consumption. So there have been some reports showing a U-shaped or a J-shaped association, such that moderate consumption is associated with a lower risk, and as you increase consumption, risk begins to go up. So there are obviously many reasons for some of these inconsistencies between these studies, and one of them, of course, could be the genetic background of the populations that are being studied. So we wanted to understand or explore the possibility that perhaps individuals with certain genotypes, illustrated here in the middle as like a black box, perhaps certain genotypes are more vulnerable, and some individuals, coffee could in fact increase the risk, whereas others there would be no effect, and yet others might actually benefit from moderate consumption. So coffee, of course, is a pretty complex beverage, all kinds of bioactives, some like the polyphenols that have antioxidant properties are thought to have beneficial effects, while others like the diterpenoids that are known to raise LDL cholesterol could have adverse effects. So it's a mixture of some good things and some not so good things. Our focus, of course, was on caffeine, and we asked the question, is caffeine a component of coffee that could act as a trigger for a heart attack? Caffeine, of course, is broken down almost exclusively by CYP1A2, one of the drug metabolizing enzymes in the liver, and it converts it into a more water-soluble compound, paraxanthine, that's again rapidly broken down into other water-soluble compounds. The nice thing about CYP1A2 is it catalyzes the rate-limiting detoxification of caffeine, and the gene that codes for this enzyme has a common polymorphism at this position that has a profound effect on enzyme activity or inducibility, as shown here on the y-axis. So if you are a carrier of the C allele, you are essentially a slow metabolizer. Whereas if you inherited an A allele from both your mother and your father, you have roughly a 4-fold higher rate of being able to break down caffeine. So we reasoned that if caffeine is a component in coffee that could increase the risk of a heart attack, then we would expect the slow metabolizers to be at a higher risk than the fast metabolizers, because the slow metabolizers cannot get rid of caffeine as efficiently, so it lingers in the system longer, and if it does have any adverse effects, you're more likely to see it among the slow metabolizers, because the fast metabolizers would get rid of it much more rapidly. Now, initially we thought the slow metabolizers just consumed less caffeine, but it turns out there was no difference in how much caffeine the fast and slow metabolizers consumed. I should also point out that in our population, roughly half were slow metabolizers and half were fast metabolizers. This ratio, of course, can differ between different in different geographic regions and between different populations, but in our population it was half. So this was a study that was conducted in collaboration with Hanya Campos at Harvard, and we looked at over 2,000 cases of first acute myocardial infarction, and an equal number of controls matched for age, sex, and area of residence. We used a food frequency questionnaire to assess coffee consumption and other sources of caffeine. And in this population, over 90% of the caffeine came from coffee. So very little contribution of essentially cola beverages and tea, other sources of caffeine. And we obtained fasting blood samples from which we genotyped our participants. So without taking genetics into account, when we looked at the association between coffee consumption and risk of MI in our population, this is the multivariate adjusted odds ratio. So this is taking into account potential confounding factors like smoking, physical activity, saturated fat intake, and a whole host of covariates. And what we found was, after taking into account those potential confounders, that consuming 4 or more cups a day was associated with about a 36% increased risk of an MI. Odds ratio of 1.36, 95% confidence intervals did not include the value of 1, so it was statistically significant. Now, if we had stopped our research there, our study would have gone on to the pile of a bunch of other studies that conclude, yes, drinking 4 or more cups a day is associated with an increased risk of a heart attack. The real question we wanted to ask was, is this increased risk due to caffeine? And if it is due to caffeine, we would expect the slow metabolizers to be at a higher risk. So when we stratified our population by CYP1A2 genotype, that's exactly what we found. On the right-hand side, the slow metabolizers, you can now see 2 to 3 cups a day is associated with a significantly increased risk, whereas the fast metabolizers, there's absolutely no increased risk. If anything, you start to see the signs of this U-shaped association that others have reported in their entire population. Now, at the time, there was reason to believe that caffeine might act as a trigger, more so among younger cases of heart disease. I believe it was a study in the nurses' health study showing that coffee increased heart attack risk in those women who were below the age of 50. So because we had a fairly large sample size, over 4,000 for a case control, and because the genotype frequency was so high, 50-50, from a statistical point of view, the numbers really don't get better than that. So when we looked at our population below the age of 50, you can see here the y-axis now changes. Slow metabolizers who drink 4 more cups a day have almost a 4-fold increased risk of a heart attack. With fast metabolizers, we now see a significant protective effect of moderate consumption. And what we think might be happening here among the fast metabolizers is because they can efficiently get rid of the caffeine, which perhaps is harmful, that probably unmasks some of the beneficial effects of the polyphenols, the antioxidants, and some of the other things that are found in a cup of coffee. Once the fast metabolizers hit 4 more cups a day, even though they're fast metabolizers, they're probably starting to saturate the system, CYP1A2, so that the adverse effects of caffeine are probably starting to counter any beneficial effects of the antioxidants that might be causing this protective effect. Now, I just want to point out that the only difference between these 4 cup-a-day drinkers on the right-hand side And these 4 cup-a-day drinkers on the left-hand side is a single nucleotide polymorphism that affects the rate at which caffeine is eliminated from the body. They smoke the same, physical activity levels are the same, every variable in our database was essentially the same between these individuals. So even though we've adjusted for a bunch of confounders, because caffeine is the only major substance in coffee that we're aware of that's detoxified by CYP1A2, this strongly implicates caffeine as a trigger for this increased risk of a heart attack. And it suggests that it's highly unlikely that this association is due to residual confounding, something else that coffee drinkers do that we just did not measure or were not aware of. Because whatever these 4 cup-a-day drinkers are doing here on the right-hand side, these 4 cup-a-day drinkers are also probably doing it as well, because it doesn't make sense that the gene would affect whatever residual confounding behavior might be at play. So we reported this just over 7 years ago now in JAMA. This kind of thing I guess the media likes to report on. This was the front page of the London Times in the UK. Why 2 cups of coffee can damage your heart. And the headline on the inside, gene that could make your next coffee fast. So it wasn't until a few years later that another group led by Paolo Palatini in Italy basically built on our findings but looked at to see whether or not CYP1A2 genotype could also explain some of the inconsistencies between studies linking coffee and risk of hypertension. And they essentially found the same thing that we did. Their results are depicted slightly differently in their graph. They put all abstainers as kind of the reference group. And on the right-hand side, you have the slow metabolizers with increasing cups of coffee, and you can see an increased risk of developing hypertension. Whereas on the left-hand side, fast metabolizers, increasing cups of coffee, decreased risk of hypertension. Slightly different cup sizes they have there in Italy, but nevertheless, you still see the same pattern. If you did not take genetics into account in the study, you would conclude that there would be absolutely no effect, because mixing these 2 populations, the fast and slow metabolizers, you would conclude there's no effect. The nice thing about this study as well is it's a prospective study, so they looked at a large group of individuals who were pre-hypertensive. They genotyped them, assessed their coffee consumption, and then followed them prospectively to see who would develop hypertension. The study has hazard ratio. Now they also looked at the association between coffee, CYP1A2 genotype, and some catecholamines. And as you can see, again, with the graph on the left, you have fast and slow metabolizers with increasing cups of coffee and epinephrine concentrations on the y-axis. Only the slow metabolizers with increasing cups of coffee do we see this increase in epinephrine as well as norepinephrine, although it didn't reach statistical significance on the right-hand side. Another group in Finland a number of years ago also reported that genetic variation, in this particular case in the catechol-methyltransferase gene, which is involved in the metabolism of catecholamines like epinephrine. And as you can see here on the graph, the dark bars refer to those who have the genotype associated with high COMT activity. In other words, they break down epinephrine quite rapidly. The bars towards the back, the light-colored ones, are those with the slow activity genotype. In other words, those who are less efficient at breaking down epinephrine. And as you can see, it's only in that group that increasing cups of coffee is associated with a higher risk of acute coronary events. Again, illustrating the importance of genetic variation, in this case, not related to caffeine metabolism, but related to epinephrine catecholamine metabolism, which caffeine is known to increase. Just recently, we reported in the Journal of Caffeine Research that COMT can also explain why some people experience increased heart rate following caffeine consumption. And as you can see here at the very bottom, the group that consumes habitually more than the equivalent of 2 cups of coffee a day. Those with the MET genotype associated with, which is the equivalent, different nomenclature, but equivalent to the low activity, COMT, they're the ones that have almost a 3-fold higher rate of experiencing elevated heart rate after consuming a cup of coffee. So just to wrap up, I think it's tried to illustrate here is the importance of individual variation, and a challenge, of course, will be to reconcile public health recommendations with personalized dietary advice. One size fits all clearly does not apply when it comes to coffee consumption, and certainly for other sources of caffeine as well. So in terms of future directions, we and others have identified certain genetic variants. There are certainly many others that probably explain other types of responses. And thinking of those several case reports of premature death following the consumption of a drink, it's highly unlikely that it's due to CYP1A2, which is very common in the population. It's probably not likely due to COMT, which is also fairly common in the population, about 30 to 40%. But it most likely is due to some other genetic variant, and we don't know how common that other genetic variant is because it hasn't yet been identified. And I think in terms of regulations, it's important to take into account those vulnerable subgroups and ensure that they are protected. So I'll just finish off with thanking the members of my group. Marilyn Cornelis was a graduate student who did some of that earlier work, and of course many others who contributed in different ways, and some of our funding partners here. And thank you for your attention.
Ahmed, thank you very much.